Okay, so just picking any number we can put. Oh, that's kind of high up there. Okay, so if we have 6, 4, 2, 7, 3, 9. So if we have 642, 739, we would start with the default position of the decimal, which would be right here. Count how many positions it takes to reach a single digit between 1 and 9. So 1, 2, 3, 4, 5. Takes 5 positions, so we'd write our decimal down. 7, 3, 9. And we move to the left, so we would have a positive number. And we would put the number of positions it took for the decimal to get to a single digit between 1 and 9. Here at the exponent, right here, of the exponential, or base, which would be right here. So we moved it 1, 2, 3, 4, 5 times. So we would take that and put it here. So we would have this. Looking at another number, we can do 0.007. So we start with the initial position of the decimal and move it to get to the first whole number. So 1, 2, 3. We moved it to the right, so it would be negative. So we have 1.0 times 10 to negative 3. Looking at another number, we could write 8924. So we would start at the default position the decimal would be, which would be right here, and count how many places it would take to get to a single number between 1 and 9. So 1, 2, 3. We move it to the left, so we would get a positive number. So our decimal would be 8.924. And we moved it 1, 2, 3 positions. So our base would be 10, and we can take that 3 and put it as our exponent. So it would be 8.924 times 10 to the third. Looking at a small number, we move the decimal to get up to the first whole number, so we move it 1, 2, 3, 4, 5, 6 places. 1, 2, 3, 4, 5, 6. So we get 1.0 times 10, and we moved it to the right, so we get a negative number, so negative 6. I'm just going to do a ridiculous number here, just to kind of push the message home. Okay, so we have this ridiculous number. So we start at the default position where the decimal would be, and we count how many places it would take to get to a number between 1 and 9. So we're trying to get right here. Oops. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 11, 12, 13, 14. So we moved it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 positions to the left. So we moved it to the left so we get a positive number. So we would get this. And then multiply it by our base, 10. And we would take this number and put it at the exponent of the exponential. So we moved it to the left so it would be positive. So it would be positive 14. And if you notice, so what this would be doing is multiplying this part right here. It's telling this number that it needs to be multiplied by 10 times 14 times. So it would be this number here times 10 times 10 times 10 times 10 all the way up to 14 times, and that would give us the original magnitude that we had. Because when we move the decimal all the way to where there's a single digit, the magnitude will shift on that. So to get it back up to the original magnitude, we have to multiply it by, we can multiply it by increments of 10. So if we multiplied it by 10 one time, we would bring it here. 2 times, we would bring it here. 3 times, we would bring it there. And so on until we would have 14 times. And the easiest way to do that is just use this base is the increments that we're multiplying it by. So, like I said, if it would start here, we multiplied it by 10 times, we could just move the decimal here. But if we had a base that was something like 12, then it doesn't fit very well. It would be so. So 10 works out well and it's perfect. It's a really easy way to do it, really. So if we had another number, I'll make this one kind of ridiculous too, just so you get the idea of what is going on. 9, so the decimal's right here, so we would have to move it to the right. 1, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Let me count just to make sure I didn't mess that up. So 17. So let's write our decimal down first. I'll just put 1.0. And then again, we're moving it in increments of 10, so we can multiply it by 10. And this is the base, or the exponential. And then we multiplied it we moved the decimal 17 times to the right. And when we move the decimal to the right, it's negative. So we take this number here and plug it in to the exponent. And it was to the right, so it would be negative. Let me write that down better.